Networks can be both noisy and unstable, which means that we need a way to ensure that the message or data packets that we send over the network is identical to the message that is received. We can use hashing to detect errors when information is sent over a network, like the internet. If an error is detected, then the system should ask that the data is resent, and this is known as automatic repeat request. So how does hashing work? First, the data is divided up into blocks of a fixed length, and if a block is not exactly the right length, padding is added to make it the right length. Then, the first block in the series will be hashed, which involves sending it through an algorithm that scrambles it in a consistent way. The output of the hash will be fed back into the hashing function along with the next block, and this process is repeated until all the blocks have been processed. We end up with a fixed length unique string where we can't go back, and if even one character were changed, the hash would be completely different. So here's a concrete example. I've got a very long sentence that actually contains some of the transcript from this video, and I've hashed it, and as we can see, we have our MD5 hash. If I go back up to the input area and change even one letter and then regenerate the hash, it's completely different. So here you can see that we had the original hash, and even one letter difference makes a big difference to our hash. This means that we can easily detect if the information that was sent is identical to the information that was received. In the DCAT, here's how you'd explain it. First, the data packet is hashed, and both the data and the hash are sent to the receiver. Then, the receiver creates a hash from the data it received. The two hashes are compared, and if they match, we don't have any errors. If the hashes don't match, then the system will ask that the data be resent. So here's a diagram showing that process where I've got my sentence. I've hashed it. I'll send both the sentence and the hash to the receiver. Then on the other end, I'll hash the sentence again, and then I'll compare the hashes. And in this diagram, the hashes do match, so what was sent is identical to what was received. In the DCAT, you will want to note that hashing is a one-way process. We can't undo the hash or work backwards to get back to the original data, which means that if the data has been corrupted and our hashes don't match, it will need to be resent. Hashes let us detect errors in our data packets, but they don't let us correct them. The good news is that hashes require much fewer bits compared with an error correction method like Reed-Solomon, which is why it's easy to use them on networks where we can easily resend the data if necessary.